Hello everyone. Today I would like to talk about the topic that is cloud computing serverless. So our group will go through all about this. So I would start with it, the serverless revolution. So that is running code without the servers. Serverless is basically doesn't means like we don't have the servers. It means like we have a servers, but that will be managed by the cloud providers. We don't manage all this. So today's agenda is about the abstract, introduction, problem statement, methodology, implementation, results, conclusion, and future work. I'll go through about this. So the abstract is about unlocking efficiency with the serverless architecture. So what is serverless architecture? Serverless architecture combines backend as a service and function as a service to redefine service delivery. So basically, like in the serverless, what we are doing, we are not managing our servers. It will be managed by the cloud service provider, and everything will be taken care by the cloud service. We don't have to take to look up for the what are the services we are using, what kind of compute we have to use. That's all will be managed by the cloud service provider. We just have to write it down the functions. So what are the core principles of it? It's eliminate the need for explicit server provisioning, like for the maintenance, management, all this will be done. The major key benefits about it is the automatic scaling, like reduce the operational costs. For example, if I talk about the technical aspects as well as in the financial term, so it will reduce the operational cost because everything is done by the cloud service provider. Whenever the customer needs the service, it will activate it, otherwise it's deactivated. So what's the focus shift? Focus shift is for the infrastructure management basic business logic, because it also impacting the business, because business saving a lot of money about it. If I talk about the introduction, like the evolution of software architectures, so software architectures we have two types: two-tier architecture and three-tier architecture. In two-tier architecture, we have a client and a server. Like if a client do the request, it directly send it to the server and it reflect back to the client. But in the three-tier architecture, there is a client, there is in between the application server, and at the end is a data server. For example, client raised any request, it send it to the application server where the microservices are working, and then that data will be transferred to the data server. Data server again reflect back to the application server, and it reflect back to the client. So that's all about the three-tier architecture. And if I talk about in this paper, like what's the problem statement they are able to identify over there. So what are the burdens of the traditional cloud computing? The first one is the high upfront cost. For example, like the capital investment for the server purchase, and I mentioned sometimes peak load, so then the cost will be high. If I talk about scaling complexity, sometimes to do the manual auto scaling, it's a bit complex task, and which leads to the downtime, costly over provisioning. Moreover, administration and maintenance. Sometimes we need a continuous updates, patching, and hardware replacement resources from them. So these are some of the major points like the cloud deployment models are facing. So these things increase the operational cost. As in the serverless, we see the operational cost is down, and that's the major advantage of using that servers in a day-to-day life. And people are moving towards more towards the serverless architecture, because there is we just have to write it down the functions, and the functions will do whatever we have write it over there. They perform their task whenever the customer needs it, otherwise they are not using any resources over there. So that is the all about. Thank you so
Okay,
much.
now let's walk through the methodology behind adapting the serverless architecture, which is one of the most popular model in modern cloud computing. Serverless doesn't mean removing the servers because the servers still exist. Instead, it is the method of abstracting away the concept of server management. That is, in a traditional setup, the developers have to manage the servers, um, deploy them, configure them, and even scale them manually. But in a serverless architecture, all these tasks are performed by the cloud provider. And this is the major shift in this methodology. That is, we are moving from manual infrastructure management to an automated event-driven execution. And in uh, in serverless architecture, we are discussing about two main models, that is BAS, backend as a service, and the function as a service. In backend as a service, it provides a ready-to-use backend functionality that can be especially used in mobile and web applications. And in a function as a service, it is one of the most commonly used model in the serverless architecture. And in this model, a developer writes a small, discrete piece of code, and this function is stateless, short-lived, and it is used whenever it is needed. And some of the characteristics of this serverless architecture is that it is ephemeral, that the code can be used only when it is needed. The second one is that it follows a pay as you go method, it's cost effective. And finally, it focuses on developer productivity. That is, developer doesn't want to worry about the code, doesn't want to worry about the server management. They only need to focus on the code. And um, one of the important performance consideration in the cloud in serverless architecture is the latency, which is caused due to the call starts with the warm starts. Warm start happens when a function is in an execution state, or was previous or was recently invoked, and is currently and its running environment is currently active. Like we said, using a heated oven, we just go and pop up the food, and the food start cooking right away. On the other hand, cold cold start means, or it occurs when a function is invoked after a long period of inactivity. Here, we need to start a new container, then invoke a new runtime, and execute the code. So the cold start affects the user experience, mostly in latency sensitive applications like chat, APIs, and etc. So, as a summary, um, the introducing serverless architecture as a methodology means shifting responsibilities from user to provider, and breaking down apps into event-driven functions, and also um, enabling faster development through built-in sustainability and reducing operational burden. Thank you.
Okay, so as my friends discussed that there are there are like several benefits of the serverless computing, but now I'm gonna discuss about what is the main benefit the developers are getting by using their serverless computing. So we know that it is providing us agility, scalability, and the cost efficiency in terms of cloud providers. But how they are helping in abstracting the main information from anything else. So how it is like preventing our resources, how the developers are getting benefit of it. So one is none other than the they don't have to take care about the internal architecture of the function. They need to only focus on the functionality of that functions, writing the code, none other than that. The next thing is the most benefit that the developers are getting is the serverless orchestration. So the orchestration is nothing, is basically binding the complete set of function or calling of the function into single workflow file. So basically, they in the real world scenario, we have like a multiple function or the API calls where we need an input from the one function, the output of the one function as an input in the second one. So the serverless orchestration provide us that feature where we are just gonna create one workflow file, and we're gonna mention the sequence of functions, how they're gonna call, and what are the inputs gonna be uh, passed from the previous function. So as I said, the implementation consists of like several steps. They like centralized HTTP server, as I mentioned, that there's a one serverless file, and everything is written on that file only. And the next one is none other than the authentication and validation. So whenever we are writing a function, it makes sure that only the authenticated person will gonna write that code. None other than the person who is not allowed to make the code changes, they will not gonna change anything there. The third one is not is the most important part, is like the traffic management. So our API is like always in danger since they are over the web. So they are always in a danger. So as a developer, we have a responsibility to manage the JWT tokens and all those validation features. But as a serverless function also provide one feature of the server traffic management. So what developers don't, so we have a kind of concept known as a rate limiting, where a particular APIs from a particular IP can only get certain amount of requests in a certain time period. If they are getting more calls than expected, then that IP is gonna be blocked and no more requests are gonna be accepted from that IP. So that is a kind of rate limiting. That is a concept of the rate limiting, and the serverless orchestration function like provide these feature to us. That fourth one is not none other than the caching and the transformation. So the caching is basically improving the response time. What we can do in the what you can understand with the help of the caching is, for example, we can take our data and cache it for, so whenever the next request come with the same input, we're gonna output the same thing like in a milliseconds. So in the first request, suppose it will gonna take 2 seconds. Whenever there is a like continuous request with the same input, then it will gonna take around like milliseconds, less than the milliseconds also. The last, but the not the least, is logging and the monitoring. So the logging is one of the most important feature which will help us to detect the issue in our APIs. So suppose if over the night we got some issue in our APIs or in our function, then we can just log that thing or monitor our serverless function. So in the future we can resolve that thing. Yes, the project that we have given, they took a traditional example of a pet store. So they have like complete website where all the details of the pets are stored, all the food items that is related to the pet, all the things all the information that is beneficial for the pets gonna be stored and that on that website. And before the serverless function, they were using the two-way architecture where the call is coming from a front end, the server is gonna call the database and the data will be written to the function. So it's like a two-way architecture where it has like a deep problem, the main problem, where if the load is certainly gonna be increased, then they have to manage it manually, and or they have to contact the cloud provider that at that particular time I'll gonna need that thing to be increased, that to be handled. But with the help of three-way architecture, we have a client in and then we have like databases. In the middle we have like a multiple serverless function running simultaneously, which will gonna handle the load which will coming from the front end. So in between we have a load balancer. Load balancer will direct the request to the particular servers, so they can handle the request as fast as possible. So that's how they remove that problem of the load, that one problem of the load, were by using the three-way architecture. And it is like a most important thing nowadays, which is helping organization, or we can say big organization, to handle the traffics efficiently.
what we know about serverless architecture. So where is it used exactly? So it can be used in some inconsistent traffic or occasional requests. So what is inconsistent traffic? So in this, if there are just normal operations going on and suddenly there you see requests are increasing and there are a lot of requests together, that's the time we need more amount of servers, we need more amount of processors to process all the requests. And that's when we require the serverless computing, where we can actually use this the automated version where the servers or the processors are increased according to the users, and it can be decreased when it is not needed. So this is when, suppose there is an Amazon sale and people are just continuously logging in and purchasing different products. So you need to have operations that are up to date and that works according to the users. But when the sale is over, you need to decrease the amount of servers or the processors, and this is done automatically using the serverless computing architectures. The second one is when there are occasional requests. So not every time you get this request, but you get this request and you want it to be processed as soon as the user logs in. So this is when you can use serverless computing, where you are thinking ahead of the time, where you know that people are going to log in onto this website, or maybe they want to access some information or something. So this is when it is used. The next one is cost effectiveness and scaling benefits. So so basically, when your resources, you're planning your resources according to the users. So when it is more, you will need more servers, you will need more amount of processors, you will need more amount of resources. But when you don't need that actually, then what happens? It decreases the number of the processors or the resources, and this actually is beneficial for the company in the cost perspective, because when you are using certain products for a continuous time, you need to invest for maintenance and everything. But when it is scalable, if you don't need it, you can just stop using it and you can start with it whenever you need it again. So this is cost benefit, this is reduced operational cost, and when you're actually scaling up or scaling down, you don't have to pay more amount of it because you already planned ahead of it and you are paying just the amount that you used. The advantages and disadvantages of serverless. So now you see that according to the examples that I've given, they show that it is a beneficial thing and you reduce the cost, it is easy to use. But what about the disadvantages? Disadvantages is like vendor login. You are using, suppose, Google, and you have to proceed with Google. So you are doing scaling in, scaling out, and everything using Google itself. Second one is cold starts. Cold starts is basically when you are switching to something new. It takes a few moments, like few seconds or minutes to start with the new thing, and this is actually taking some time, and this can be affecting our business. So this is a disadvantage for us. The third one is debugging and monitoring complexity. Now, when the resources are increasing and decreasing, and something gets added, something is decreasing, so how do you monitor that? It becomes a difficulty. It becomes a debugging difficulty as well, because you need to know that what exactly the issue was and you need to solve it. So this is a disadvantage in this. The last one is the future scopes. So where can we improve in this to improve our production? So you can use the component group development, where streamlined development of related functions as single logical unit. You don't need to program different things. You can just use a simple program, a single one that can use different logics to complete the task. Maybe you can go for enhanced remote debugging that can be useful in debugging the issues that we face in the serverless computing environment, where we need to debug multiple things and we need to find solution and we need to implement that. So this can be useful, and there are many other ways where we can improve our production. Thank you so much.